Hi, in this video I'll be talking about clouds. In the first part of the video I will cover the 10 basic cloud types, give a brief overview of each one, and explain how to identify them from one another. In the second part of the video I'll cover some common cloud indications of oncoming weather patterns. It may seem confusing at first, but clouds actually follow a predictable naming system, with every cloud name derived from these Latin words: stratus, cumulus, cirrus, or nimbo. The two most important ones to remember are stratus and cumulus, as almost every cloud takes on an aspect of one of these two. In Latin, stratus means spread out or flatten out. These clouds cover the sky with a layer. They are flat. Cumulus clouds are the opposite. Cumulus means heap, pile, or mass. These clouds are puffy and take on individual shapes rather than a uniform blanket. A good way to remember them is by the word accumulate, which is what these clouds do. Moving on to cirrus. Cirrus means curl or lock of hair. These clouds are defined by their wispy, thin, or tendril-like appearance. All cirrus type clouds are high level, which I'll get more into in a second. Our last type is nimbo. Nimbo clouds are just rain clouds. Now here are the 10 cloud types. There are 3 levels. High-level clouds have bases above 20,000 feet. As you can see, they are all cirrus types, with cirrus, cirrocumulus, and cirrostratus. Commercial planes will be flying around the altitude of these clouds. Mid-level clouds, altocumulus and altostratus, have bases between 6,500 and 20,000 feet. They have alto preceding their name, which classifies them as mid-level. Low-level clouds, stratocumulus, cumulus, stratus, and nimbostratus, have bases below 6,500 feet. And finally, cumulonimbus clouds, which have such significant vertical growth that they can have bases on the low level and grow all the way to the high level. It's worth noting that there are often a mix of cloud types in the sky at any given time. Differentiating them takes experience and time, so my goal for this video is to just give a basic overview and provide a starting point for people who are not knowledgeable but interested in clouds. Now that we know the naming and level system, we can look at each cloud individually. We'll start with high-level clouds, which have bases above 20,000 feet. These 3 clouds, cirrus, cirrostratus, and cirrocumulus, are mainly composed of ice crystals due to their high elevation. All clouds that are not high level are not mainly composed of ice crystals, and instead water droplets. All high-level clouds also indicate immediate fair weather and do not produce precipitation that will reach the ground. These clouds are very identifiable just by their high level. All cirrus-type clouds will look far away. Now let's get into each type. Cirrus clouds are easy to identify. They are wispy and have strands. They do not cover the entire sky. As seen in the left picture, they can take on larger shapes, but looking closely we can see the wisps at the end and observe how the general shape seems spread out and thin. Moving to cirrostratus. Cirrostratus clouds are more uniform and less stringy. If you remember, stratus means to cover with a layer, which is what these clouds do. They create a thin sheet over the sky, which the sun and moon can still easily shine through. A halo effect is sometimes caused by these clouds, due to the light reflecting off the uniform ice crystals. The final cloud of the cirrus family is cirrocumulus. Cumulus clouds are heaps or piles and take on individual shapes. This is visible in cirrocumulus clouds, which are puffy, patchy, and do not cover the entire sky. They have texture, but are small and have no shading, which is how you can differentiate them from other cumulus-type clouds. There are only 2 mid-level clouds. Altocumulus and altostratus clouds have bases between 6,500 and 20,000 feet. These clouds rarely ever produce precipitation, and even if they do, the precipitation will probably not reach the ground. Altocumulus clouds are thin and have texture. They indicate fair weather. Altocumulus clouds are similar looking to cirrocumulus clouds, but there are some key differences. While cirrocumulus clouds are mainly white with minimal shading, altocumulus clouds are white and gray with light shading. Altostratus clouds are grayish-blue. They cover parts of or the entire sky. The sun can still shine through them, but vaguely. They can have ripples, as shown in the top right picture. They indicate overcast and sometimes very light rain. They can be differentiated from cirrostratus clouds as they are thicker, more colored, and the sun shines through much more vaguely. They also do not produce the halo effect of cirrostratus clouds because they are made of water droplets, not ice crystals, meaning the light doesn't reflect the same way. They can be differentiated from stratus clouds, as while stratus clouds are low level and seem like they are right above you, altostratus clouds are clearly higher in the sky, and the clouds feel more like clouds rather than haze or fog. There are 4 low-level clouds with bases below 6,500 feet: stratocumulus, cumulus, stratus, and nimbostratus. Stratocumulus clouds are one of the most common clouds globally. They combine aspects of stratus and cumulus, as they cover the sky like a sheet, but take on a sort of puffy shape. Often they form in lines across the sky, or form groups. They will rarely bring light precipitation and are associated with fair weather. They can indicate improving weather as they commonly form after a thunderstorm or after a front passes. To differentiate them from other clouds, you can notice the shape and texture. Stratocumulus clouds are sheets, but they have puffiness. They also usually come with lines that show they are a bunch of shapes clumping together rather than one uniform blanket layer. Cumulus clouds are your classic happy clouds. They're the clouds you can spot things in, like a dinosaur or a chicken. They are defined by their individual shapes and puffy, large appearance. They indicate fair weather and do not bring precipitation. Stratus clouds are flat and featureless. They are light gray. They are a uniform layer and have no real texture. They are associated with overcast and can bring light precipitation. They are different from other stratus-type clouds as the sun slightly shines through or does not shine through them at all. They will appear right above you and almost feel like a lifted fog right above the ground. They are different from nimbostratus clouds as they are brighter, a lighter gray, and less dense. Nimbostratus clouds are dark gray. They are associated with overcast and dark, sunless weather. They bring precipitation and are one of the 2 rain clouds. For the last cloud, we will look at cumulonimbus. This is a multi-level cloud with a base starting below 6,500 feet that can grow over 6 miles high, which is around 32,800 feet. It can be equally large in width. These clouds are defined by their anvil-shaped tops, which occur when the cloud hits the edge of the troposphere. They have dark, hazy bottoms. These are evil clouds and produce violent precipitation. They are the only clouds that can produce hail and thunderstorms, and even tornadoes. So what about no clouds? If there are no clouds in the sky, that's a sign the air may be dry. Storms are less likely to quickly form with the absence of clouds. If there are no clouds in the sky, the weather will probably remain fair and stable for the coming future. Now that we know all the cloud types, what they might indicate, and how to identify them, let's look at some common weather patterns that are associated with cloud changes. It's worth pointing out that clouds by themselves can't tell you much about the future weather, so the most important aspect of weather prediction based on clouds is observations over time. Changing clouds can tell a lot about what might happen in the following hours or days. Thunderstorms can form within hours and appear in an afternoon that otherwise seems normal and sunny. The main thing to watch out for is vertical cumulus cloud growth. This can happen noticeably over 30 minutes to an hour. Within 2 hours, a full-fledged thunderstorm can be downpouring above you. Here is a cumulonimbus cloud near Denver, which really captures the massive scale of these things. Now we will discuss fronts. Fronts are the boundary that separate 2 different air masses. Fronts are responsible for the majority of precipitation around the world. We will be looking at 2 different types: warm fronts and cold fronts. First, we will look at a warm front, which we can see demonstrated in this image. A warm front is when a warm mass of air runs into a cooler mass. Because the warm air is less dense and more buoyant than the cold air, the warm air slowly rises. As the rising warm air gets higher up, it cools and condenses, forming clouds. These clouds often produce precipitation as the warm front causes a significant amount of moist warm air to rise gradually. The precipitation that is produced by warm fronts tends to be steady, light to moderate rain. The indication on weather maps for warm fronts is the red bumpy line that is shown in the top right of this image. We will now look at how clouds can predict warm fronts. Cloud indication for approaching warm fronts tends to be revealing. The first thing you will notice before the arrival of a warm front is the thickening of cirrus-type clouds, and a change from cirrus to cirrostratus. This will happen 12 to 36 hours before a warm front arrives. There will also be a gradual wind increase. As the cirrostratus clouds continue to thicken, altostratus clouds will begin to form and take over the sky. These indicate the warm front is near. Altostratus clouds will turn into nimbostratus clouds as the front arrives, producing rain or snow. Now onto cold fronts. A cold front is when a cold mass of air advances into a warmer mass of air, causing the warm air to rapidly rise. Unlike with a warm front, the warm air here will rise very quickly and steep, causing instability. Out of this, cumulus and cumulonimbus clouds are often formed, bringing more severe weather. On a weather map, a cold front is indicated by the blue line with triangles, shown in the top right of this image. The early signs of an approaching cold front are very similar to a warm front, with thickening cirrus-type clouds and an increase in cirrostratus clouds 12 to 36 hours before arrival. The wind increase from an approaching cold front will likely be sharper and more severe than that of a warm front. With cold fronts, mid-level clouds are a lot less common. While altostratus and altocumulus clouds may form with the approach of a cold front, the main indication is cumulus and cumulonimbus clouds forming. Cumulus and cumulonimbus clouds are significantly more common with cold fronts, as cold fronts cause a much bigger disturbance in the warm air as it rises rapidly instead of gradually. While cold fronts bring harsh precipitation and sometimes thunderstorms, it is much shorter lived. Warm fronts produce long, lasting, more moderate precipitation due to the warm air's slow rise. I hope you enjoyed my video and found it interesting. This was a brief overview of the 10 cloud types and how they behave around some common weather patterns. Next time you're outside, try to identify some clouds.